What's up, everyone? Welcome to today's stream. Another quick and short one before our big session on a Tuesday. I'm going to show you how I set up my render scenes so that they work efficiently and so that I can preview things properly using Cycles Render in Blender. So let's get right into it. I'm going to get into Blender over here. So I'm going to start in a new file. And in this new file, I'm going to drop in the camera setting that I was working with last time so that I have a driving composition for this scene that's going to match the previous video that I was working on. So I'm going to go right here into, looks like this file. It might be lost or hopefully not. Might be okay. Let me open up my chat as well. So if there's anything along the way that I'm explaining that you'd like to see more clearly or anything else you'd like me to add onto or explain on, you can always add that into the chat and I'll do my best to respond to that in a moment. All right. I had a bit of a glitch here on my streaming computer. Hopefully we're doing okay now. Okay. So what I want to do here is just bring over the camera that I was using in this scene. So I'm going to copy it and then I'm going to paste it over into my new file. Paste objects, and there we are. I'm also going to copy this square here that was functioning as my base platform, a kind of foreground element for the scene. And I snap into the camera view and I can see there that cell. So I'm going to start working off of this first frame, which would match the same frame as the other scene, as the other file that I have going on, and work backwards from there. So I will close out that file and then start setting up my render scenes in this one. So saving the file. Now, I'm going to start over here on the properties panel and go to render properties, and I'm going to switch over into cycles, right? That's what we're going to be using to render out over here. I'm going to set it over to GPU so that I'm using the proper hardware that's going to optimally work the render. Next, under sampling, max samples 1024. It defaults to this number, but this is actually like a much larger number than we might need. Typically, I'd go to 32 for the viewport view. And for the render, max samples 4096. That would work if it were an interior scene with low light. If it's an exterior scene and there's a decent amount of light, and even 600 or 900 might be high. It always depends throughout different scenes, but I noticed that maybe 300 to 900 is maybe the sweet spot between speed and quality. But in this case, I'm showing you how to get your most optimal results in the viewport. So for the viewport, we're going to set it at 32. And we want to turn on that denoiser, right? That denoiser is going to actually show us a much clearer image before we're supposed to by using AI rendering. So the one that I use for faster rendering in the viewport is optics. I end up using open image for the actual render later on. It does come out with generally better quality, except I've mentioned this before, in some areas where there's low light and there's no foreground elements, or it just kind of goes off intimately into the background, right? Open image denoise sometimes does like this weird like shrink wrap effect when there's low light and not many elements in the foreground or background. So I'm going to keep it as it is here. So optics for the denoiser, albedo is fine. And the start sample, I don't need it to start denoising right away. So it can actually speed up a lot faster into the first few samples if I set this to a higher number, like say 12. So for sampling, again, we have on the viewport here, max samples 32, denoiser optics. Okay. Moving on, under advanced, typically I leave this as it is. There's not much to do here. You could set a minimum light bounces if you're maybe having an exterior scene where there's not that many translucent elements or not many elements reflecting a lot of light. You might want to limit the amount of light bounces or put a minimum amount to make sure that you get enough if you actually have a lot of that in your scene. But in this case, or generally speaking, I don't go into those settings too much. Light paths, we can control this depending on what it is that you have in your scene. So if there's a lot of reflective elements and that seems to be taking up a lot of render time, you can put down the number of light passes that you do on your glossy surfaces. Depending on the amount of volumetric elements that you might have, such as smoke or fog and things like that, you may want to put a maximum number for the volume. So at 0, there is no maximum. It'll keep doing the total number of passes that it's supposed to do. But definitely having some fog in the scene slows down your renders. So putting a maximum here for max bounces can help a lot with the render if you achieve that baseline that you want for your ambient effects using the volume setting. Next, clamping. So this will actually limit quite a bit the amount of noise that you're getting in your image, but it could very much affect the result of the render after the denoiser kicks in. So if you clamp the direct light or the indirect light too much, you may not actually be getting enough noise in your scene in order for the denoiser to do its job properly. But this is something I typically leave on its own as well. Caustics, this is a new setting. If you don't have any water reflections or any sort of elements like that, you might want to turn caustics off, but caustics can be really handy when you have curved objects or organic looking objects that have some sort of translucency and transparency to it, because this will actually help a lot in the way that the render will bend light and make it more efficient to achieve those photorealistic results with less samples. So typically I leave these on because they do help with caustics if they are in the scene. Next, moving on, the other elements here are actually more for stylizing or for render quality. They don't do too much on performance, but we can skip down into the performance section. And here, if you're opening with a default file, you definitely want to make some changes here. So first of all, you want to auto detect how many threads you have on your CPU. Definitely. You want to use tiling, and different computers will be different, obviously, on what is going to be optimal for the tile size. And that's going to depend on what CPU and what GPU you're using. The number that's here is way, way too large. Like if I'll show you real quick, if I'm rendering an image that is HD, like shown here, and I left it in the default, which is having that tile size, when I hit render, it'll pretty much, one tile will pretty much be the entire image, right? Which is not ideal later on when you're trying to get your final result. So what we want to do here is actually take that down there to 256 or to 512. It was a pretty comprehensive study done by the YouTuber Blender Guru that actually tested a lot of the different tile sizes. And it found, I think it was for him, like 256 with the sweet spot and 512 trailed just below. But I find that 512 can sometimes be faster for me than 256. But that range, or one of those two numbers, 256, 512, tends to work best here when you're outputting your final render. Now for the final render, this persistent data setting, you do want to click that on if you're doing an animation. It doesn't hurt if you're just doing a still image, but if you're doing an animation, persistent data will use, I mean, it says it right there when I hover over it. Keep render data around for faster re-renders and animation renders at the cost of increased memory usage. So you have a good amount of RAM in your computer or a good amount of memory on your GPU. I'm using a 3070, which I believe has around 8, or I do have 8 gigs on my 3070. And I have 32 gigs of RAM on my laptop. So those numbers are fine for keeping persistent data on. I'm not worried about having too much memory on my computer, especially since my scene right now is blank. If I were to overpopulate my scene later with elements, I might want to turn that off. Baking can help quite a bit down the line, but that deserves its own video. I'm not going to get into that now because it is a very complex, there are complexities to baking and nuances that need to be sort of dedicated into its own video for that, how that would work. copy settings is a Blender add-on that you could turn on by going to Edit, Preferences, Add-ons, and search for Render add-ons. So under here we have Render, Copy, Render Settings. And that will actually allow to copy render settings from other files or for different optimized situations. So for example, we have here multiple views. I saw here, like, depending on the resolution or XY that you're using, you can optimize for FPS and so on. So that's a very useful add-on if you want to turn that on. Okay, moving on from copy settings. This isn't so much for the performance, but we'll talk a little bit about color management. Typically it's set to filmic, which can be really good, but I would push this into medium high or high contrast, and I'll show you the differences later. But for the final render and when I'm really tweaking those materials so they look photoreal, I always work in filmic log and then in high, very high contrast. And that just gives a bit more of a photoreal feel, as filmic log is typically what is used for DSLR cameras, or the way that the sensor on a DSLR camera will capture light for the image is filmic log. Now that that's said, I'll kind of show you this in action. So I will scale, now I'll leave that as a scale that it is. What I'm going to do is I'm going to add some modifiers to the surface so that I can array it around my scene. So I'll just add a modifier for arraying, and I will add it in the X direction. So I'll actually also click down here to duplicate it so that I can create more than one array off of this one. There we go. And by switching this value here from X to 0 and then switching it over for Y, I can now begin to array in the different axes. So X being red, Y being green. There we go. What I actually want to do is I want to create some separation between them. So I'll put 1.25. And then I'll do the same thing for, that's a bit much. I'll do 1.1 for this one. And I will do 1.1 for this one. Okay. And for the purposes of showing you the scene, I'll go ahead and save this, and I'll move this more into camera so we can see. Increase the count numbers here so I can fill out the scene. Now, to have this run a bit more optimized as well for my preview, what I can do is I can turn off the subdivision that I'm using here. So the subdivision helps to have the detail of the texture that shows up on the surface to actually show the proper displacement and proper material properties that it should have. But I can turn it off here under the real-time button, this monitor, so that it's not actually showing in the viewport. So this should speed up quite a bit if you want to have those subdivisions show up in your final render, but if it's slowing down your viewport, turning down that modifier or disabling that modifier for the real-time viewport will definitely help. Okay, so now that I have all that arrayed, let's go ahead and see how the render is performing. So there's not that much light. We can actually see that I'm also, so my scene is actually, these objects are scaled really large. So what I need to do is here is hit N and go to view so that I can extend my clipping range for the camera. So I can extend this number here all the way to say 4,000. All right. And if I begin to introduce a bit more light into the scene, like right there, just by changing my world settings. There we go. So this is actually a pretty complex material for the render to be working on right now, because it is a water material that has quite a bit of detail on it, but it doesn't start to show that detail until you zoom in quite a bit into it. I'm actually not even able to zoom in all the way to see all that detail because of the scale that my scene has. But in any case, what I'm trying to show here is that we're actually able to work very, very quickly in cycles with those settings that I set up. So if I start adding new geometry, I could start to actually preview how those reflections are going to play over those other objects. And I can actually, if I wanted to do what I typically do here and split off my camera view over to the side and keep working over here in the 3D view. If I go to my original one, which is this one here, and hit tab so I can start editing, I can add an object into this one. So I will add a plane, and it added it at the origin. So I'm going to undo. I'm going to shift right click so that the origin moves over to the surface, and I'm going to add that plane again. And now I can move this plane over to the side so that it's part of this object. And the reason why I'm going to keep it as part of this object is so that it copies over to every object that's arrayed. So you see there, if it extends beyond, it'll actually change the spacing between the objects. So if I keep it under the original width, that right there is fine. I'll scale it on the x-axis. I will turn off my environment because what I want to do is actually change the material from this object to something that is emissive. So in order to do that, I'll just go into wireframe, go into surface mode up here, face mode, select that one, add a material slot for the object, just create a new one. I'll go down into emissive and I'll set it into this teal color. And next, what I want to do is scroll back up here. Since I have that face selected and I have this material slot selected, I can assign that material to that face, and we see it showing up here now on the left. I can Shift D to duplicate this face, and I'll do so, moving it over to the middle, rotating it 90 degrees on the Z, bringing it over just to create this effect of sort of different cells that are arrayed, or different oceans really that are arrayed separate to each other. So I actually don't need that one on the side. I could do that on its own. Okay. Hit tab to exit out. We see here in the scene, we're not getting much out of that emission. So I'll go ahead and increase the intensity for that material. So it's set to 1. And if I put it up, we'll start to see it light the scene. So it's taking quite an amount of light bounces. I mean, it's also not optimally positioned. If I select these two once more and I move it up, I can preview in real time how it starts to affect the surfaces around. So we're really only getting some reflections on the water from this light. So if I want to see a bit more, I need to diffuse more how this light is interacting with all these surfaces. In order to diffuse that light, something that I mentioned before is we can add volumetrics. So I'll go to the center, hit Shift A, select the mesh circle, UV sphere, not a circle. And I'll blow that up so that it sort of houses all the elements here in the scene. I'll increase my clipping range so you can see what I'm talking about. So we see that the sphere is actually containing everything in the scene at the moment. I'll create a new material for it because it is getting hit with the emissive material or the light from the bars. And I'll go ahead and right click here where it says principled BSDF. Not right click, sorry, just regular click. Remove that material, go to volume and add in a volume scatter. There we are. Now, the density that it always comes in at for default is going to make it way too dark to see anything. So I'll turn that down to 0.001. And now we see that the amount of brightness is actually diffusing so much from these light bars, right? The intensity is so high up that it's diffusing like crazy over the fog that I've introduced into the scene. So I got to turn that down now from 950. Let's try almost half that. 400, even less. 100. Okay, maybe 50. There we go. So as I turn it down, we start to see we get that ambient lighting from those light bars, and we see it affecting or revealing all of these different surfaces. In order to get a bit of more context, just to wrap up, and remember, I have it running in real-time cycles over here on the left, right? That's the whole point, is I'm throwing in fog into the scene, I'm throwing in reflective materials, I'm throwing in emissive materials, and even though it's still simple and abstract, I'm able to preview this quite quickly. And you could actually start to see some of that shrink wrap effect I was mentioning from where there's low light from the denoiser. So that actually won't show up at the end when we actually use the open image denoise, because we'll have to mitigate that through more light samples. So I'll go ahead and do Shift A again to add a plane, move it a bit underneath and scale that up. Scale it way up. There we go. So having that underlying surface also helps the lighting bounce within the scene and keep it all contained so that it's nice and futuristic looking. But what I'm actually going to do with that plane, if I go into solid mode here, I'm going to use one of the materials from, I bought this material pack from 3D Ducky, is his name. He's a YouTuber and he came out with this material pack. It's all procedural materials. So I can select something like under practical. He should have over here some marble materials that I can use underneath, which can start to look pretty techy. So I can add material to the surface underneath. And so I introduce another level of reflections here by adding that marble underneath. I'll actually mess with it so that the color is a bit more orangey to contrast the teal. I can always open the preview here and see how that's looking. And make it a bit more rough, so it's not a mirror image of what's going on above, but there is some reflection, right? Very nice. I can add some more detail, a bit more roughness. I can change the scale of the shape. So again, those settings that I set off in the beginning, don't have the craziest hardware. I have pretty decent hardware, but again, I'm able to throw in these procedural materials, make these changes in real time, not only preview what's going on the left-hand side, which is what we are seeing through camera, but I'm also able to see the preview on the right-hand side for the actual material. So these are the best settings that I typically have found to work best universally through many, many different types of scenes. If I wanted to make this even a bit more interesting, I could scatter, say like different cubes over all these surfaces. So if I add in a cube, make it a bit larger, and this is where I'll end it. I'll just end up scattering this cube all over the geometries. There's a way to make the cubes then be different sizes, but for the sake of explaining and showing here how these render properties are actually helping a lot with the render, we have a reflective material, or two sort of semi-reflective materials. One that is water, which are these main shapes over here, the main squares, the main tiles. We have an emissive material, which is this light bar that's arrayed all over. And we've got the sphere, which is introducing volumetric fog into the scene. And yet I am still able to, within a few samples, really, we start seeing here the sample count. We start to be able to see that within, seconds, I get the 32 samples through, which is enough for me to see what's going on with the scene. And the denoiser's kicking in, I think, at around 12 samples. I could actually bring that up since it's going so fast. I'll bring it up to 100 samples so we can see what introducing a bit more light to the scene looks like. Okay, so let's scatter this cube all over and see what that looks like. I will select the object that has arrayed and go over into the particle systems here. And I'll add a new particle system. Switch it over into hair. And here we have the number of particles I will have. The seed is kind of like a random determining number for the arrangement of the particles on the surface. But I want to go down into render, and rather than rendering in the water material and as a path, I want to render as an object. And here now I'm able to select that object, so I can just grab the eyedropper, select the cube, and figure out why I don't see it. This should be working already. Keep the object scale, keep the object rotation. Perhaps it's not arraying it underneath, is it? Nope. We'll try a different one. I'll try to render as a collection and put the cube in its own collection. If I go back over here, render as a collection. Oh, you know what perhaps it is? I didn't, so even though I scaled up the cube, I didn't apply the transformation. So I actually have to go into tools. Was it tools or item? And hit Control A. There we are. So it won't actually transfer those new scale properties that you did to it until you do Control A and then you apply all the transforms. So now the new size of the cube is set. And when I select this object in order to scatter it, instance collection, collection cube. Yeah, still nothing. Let me try with the bottom plane. Maybe there's something that I did to the arrayed surface that doesn't allow me to have this particle system set over it. There we go. So it seems to have worked with the surface underneath, although they're on the other side. That's all right. I'll just flip the surface by rotating it over. So now we have this particle system of cubes all over the place. And I'll go ahead and edit this cube by extruding this piece vertically. I guess I don't want to use the object rotation, or I want to rotate the object. Let's see. Object, set origin to geometry. So with this particle system, I am starting to feel the effects of the render slowing down. But keep in mind, we did spread about, what was it, 1,000 something cubes? Yeah, 1,000 cubes before we started to notice a lag. And we did introduce some volumetrics, as I said, some reflections and some emissive materials. So as far as what you're going to get in terms of live render performance with all these objects present, this is not bad. I'll make this file available for download, so you can use these render settings yourself. But for now, that's all I'm going to go over today, because tomorrow will be a longer session where I actually use this scene and have it work fluidly with the other scene, so the two cameras work together to create a transition from one scene to another, basically going from an aerial view of all of these different sets and zooming into one of these, revealing that it's actually its own little hub of a digital world. And so that'll be the transition between this sort of dark scene, and then once we actually zoom into one of these platforms, we'll start to experience the different lighting that actually exists within that digital world as part of the story. So thanks for tuning in. Hope this helped, showing or being able to test what these different render settings do under different conditions and knowing what those parameters for testing a render are, right? Having reflective surfaces, having transmission through your scene, having volumetrics, having emissive elements, subdivided elements, arrayed elements, etc. So yeah, again, thanks for tuning in. I'll catch you on the next one. This has been Julian, thevisualmode.com. Bye.